Welcome class to 13.1 right triangle trig ratio notes, and we're going to be talking about right triangle trig ratios. Now we're doing a mix of solving and just writing things out. So on this one we're not going to really solve much. We're just going to write all these trig ratios out. So notice we have the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Now notice, I'm going to highlight some stuff. Notice that the sine here and the cosecant are the same thing. It's upside down. Notice the cosine and the secant are the same thing. It's just they're upside down. Notice the tangent and the cotangent are the same thing but upside down. And that's what this means. That's what this means. It means that they're the same thing just upside down. That's what the reciprocal thing means. Okay? So notice opposite hypotenuse and then hypotenuse opposite. So they're the same deal, they're upside down. So we're going to find all 6 of those. My pen's going to work. My pen doesn't work. Hold on a sec. Alright, so step 1, we need all 3 sides. So step 1, we're going to do the Pythagorean theorem. Okay, that's a squared plus b squared equals c squared, where the c is the hypotenuse. So I'm going to say hypo for hypotenuse. So that's here. It's going to be this x there. So we're going to do 9 squared plus 11 squared is equal to x squared. So 9 squared is 81. 11 squared is 121 equals x squared. We're going to put those together here. So that's what 202 equals x squared. Then I'm going to square root. Okay, so let's see what we got. Okay, I'm going to double check my math with my calculator too. So 9 times 9. 121 times 11 times 11, then 121 plus 81. And then we're going to square root that. So we're going to get 14.21. Another way to do that is to simplify it, but there isn't really any way to simplify it. So we're going to keep it as this right here. That's good. So either there's simplest radical form, which is this one, or the decimal is going to be fine. The textbook likes to keep it in radicals. So that's what I'm going to do. So I'm going to keep it in I'm going to use this form here. Okay, but if you want to use the decimal, it's fine. The book and the answer key likes to use things in simplest radical form. So we're going to use that. So this isn't too hard now. Now we just have to find theta. So I want to get a different one. Here's theta. Okay, so that means over here, this is the hypotenuse. Okay, it's hypotenuse. Over here, this 9 is going to be the opposite. And it shouldn't be too hard because it's the opposite of the theta. And then this here in green is going to be adjacent. And then we're just going to put all these numbers in. So let's do the sine theta equals cosine theta equals tangent theta equals. And then we have cosecant of theta. So I'm just copying these down in a row. Secant of theta and cotangent of theta. So sine of theta is opposite over hypotenuse. So the opposite is 9. Hypotenuse is root 202. So we could do 9 root 202. We'll talk about this in a minute. We're going to just leave it there. Then to do the cosecant, you just flip it upside down. Okay. Cosine of theta is adjacent over hypotenuse, so adjacent to 11 over the hypotenuse, which is root 202. And then we're going to flip it upside down. And then tangent is opposite over adjacent, so opposite over adjacent is 9 over 11, and then 11 over 9. We're done. Okay. Now I do want to highlight some things. This over here and this over here. That's not how the textbook or any answers would ever be written. You can't have roots in the denominator. So we need to times top and bottom by root 202. So the perfect answer would be this. Now if you notice there's just a little shortcut. The root goes to the top and then you keep the bottom without a root. So this is the real answer there. And then the real answer here would be, I'm going to use a little shortcut that I know. That's going to go to the top, root's going to go to the top, denominator is going to stay without a root. Okay, that's the perfect answer. Number 3, same deal. Okay, they just give us a sine root 2 over 4. But what I need you to see right now is that is a triangle. That's what I need you to see. So we're going to draw a triangle. Here's a right triangle, and then pick theta. Here's theta. Sweet. So then opposite would be over here, and then hypotenuse would be there. Okay, so notice this right here on top is the opposite, and this is the hypotenuse on bottom. Okay, and so I put that in my triangle. This is the opposite of the theta, that's the hypotenuse. So you just pick a theta. It doesn't matter where you pick it, because if you have the triangle, you pick it the other way, it'll be just, everything will be backwards. That's it. So it's fine. So then now we need to find x. Okay, so I'm going to call this x here, and so we're going to do the Pythagorean theorem. So root 2 squared plus x squared is equal to 4 squared. So this equals 2. When you square root, nothing happens really. Subtract 2. So we get x squared is equal to 14. We square root it, so x is going to equal the square root of 14. If you'd like to take a decimal, that's fine, but I'm going to leave it like that. Okay, then we're going to write out all our trig. So here's sine theta, cosine theta, and tangent theta. I'm just writing in a row, and then I'm going to write a row again. So cosecant theta, secant theta, and cotangent theta. And then we need to label this. Okay, so this was the opposite, this was the hypotenuse, and this is the adjacent. And the reason why you know that is because theta is right here. You have to check theta. Here's theta, all over here is opposite, that's adjacent, longest side's hypotenuse. So now we're going to write the answers. So sine is opposite over hypotenuse. It's already written for us. It's root 2 over 4. Then cosecant is adjacent over hypotenuse. Adjacent is 14, root 14. So we have root 14 over 4. And then tangent is opposite over adjacent. So that's root 2 over root 14. Okay, and we're going to fix this here. And then these are going to just flip upside down. So we have 4 root 2. We have 4 root 14, and then we have root 14 over root 2. That's a great answer, looking for a B kind of thing. A, we need to fix all our roots, okay? So we can't have any roots in the denominator. So we're fine here, fine here. This has a root in the denominator, so we could also divide this out. So root 2 over 14 is the same thing as root 1 over root 7. Which is 1 over root 7. And then I'm going to do my little shortcut. So the root's going to come on the top, and the root's going to fall off the bottom. So then I would rewrite this as root 7 over 7 for that A. Same here, I'm going to do a little shortcut. So this would be 4 on top, root 2, because I'm going to move it to the top, and the root on the bottom is going to fall off. Notice that's going to simplify. So 4 divided 2 is 2 root 2. Do the same thing here. Root's going to go to the top, root's going to fall off the bottom. I can simplify those so that I get 2 root 14 over 7. That's good. And then here we're going to copy this one here. So we're going to get, well, we can simplify it here. Just divide this out. It's root 7. Yeah, divide it out. See, 14 divided 2 is 7. So that'd be our A answers there. So if you could just sign them up or write them out, you're golden. And then if you want that A, go back through and fix them all so there's no roots in the denominator. Okay, it says find the value of x and y, rounding answers to 2 decimal places. So we're going to use a calculator for this. I'll show you how to do it. First, we need to identify theta. Here's theta. Next, we need to identify our sides. So this is adjacent, this is opposite, this is the hypotenuse. Okay? So notice we have the adjacent. So that's I'm going to highlight this. So here's the adjacent here, and here's the adjacent there. So that means I'm going to use those to solve. Okay, so notice what I have tells me what I'm going to use to solve. So I have cosine of theta, which is 40, this time, 40 degrees, is equal to the adjacent, which is 7, over the hypotenuse, which is y. Okay, and then I'm going to write the other one out. The tangent of theta, which is 40, is equal to the opposite, which is x, over the adjacent, which is 7. Okay. Now, what we're going to do is we're actually going to change this. I'm just going to put this in the calculator. So make sure your calculator is in degrees mode. We talked about that before. Mine is in radians. So I'm going to change to degrees real quick. And I'm going to hit cosine 40 in my calculator. And it gives me 0.766. So I'm going to cross this out, and we're going to write this as 0.766 over 1 is equal to 7 over y. So I turn it into a fraction. I got rid of this. This is just a decimal. Then we can cross multiply here. So we get 0.766y is equal to 7. And then we divide. We're going to divide by that decimal, 0.766, 0.766, and get y is equal to. So 7 divided 0.766 is 9.14. And I'll just do 2 decimals at the end. Here I'm going to do the same thing. I'm going to hit tangent my calculator and hit 40. That is 0.839. So I'm going to cross this out and write 0.839 over 1 is equal to x over 7. Then we're going to cross multiply. So we get x is equal to 7 times 0.839. That's 5.87. I'm going to just round it to 2 at the end. So I use 3, and I round to 2 at the end. Okay? And that's it. We're done. Okay? Not too hard. All right, number 10 here, same deal. It says using the diagram to find the given measurements. So you can actually start finding all this stuff. So A is 39 degrees, so this is 39 degrees. And C is root 17. Okay, and then now we need to, here's theta. And so we need to label our sides. This is the hypotenuse. This is the opposite. And this is the adjacent. Okay, so we are given the hypotenuse. So the hypotenuse is here and here. So those are the two that I'm going to solve for. So we have the sine of the degrees, which is 39 degrees, is equal to the opposite, which is A, over the adjacent, or over the hypotenuse, which is root 17. And then we're going to use the cosine of theta to solve, which is 39 degrees. And that's going to equal to the adjacent, which is B, over the hypotenuse. Okay, and then I'm going to put these in my calculator. So sine 39 is 0.629. So 0.629 over 1 is equal to A over root 17. I'm going to cross multiply. I'm going to have my answer. So we're going to times this by root 17. I get 2.59. Then I'm going to find cosine of 39. This is 7/7, those 3 7s, so 0.777 over 1 is equal to B over root 17. We're going to cross multiply. We get 3.20 equals B. Isn't that easy? Isn't this stuff easy? That's the thing, is you learn trig when you're at geometry, and it's so hard, but it's not that hard. All right, so I'm going to run short of time here. I'm going to call this person's height x, and then this is an angle of elevation because it's going up from the ground. Depression is coming down, so this is elevation. So we have theta, it's here. We need to label our sides. We have an adjacent and an opposite. We don't need to find the hypotenuse. So that means we need to do something with both of those, which is tangent. Okay, adjacent and opposite. We have the tangent of 16 degrees is equal to the opposite over the adjacent. And then from here, you just put in the calculator, cross multiply, and solve. Okay, same deal. All right, not too hard today, just a lot of vocabulary-based stuff. If you have any questions, let me know. Have a great day, class.